All right, guys, we're gonna get started. Welcome to the second part of networking. Yeah, I guess you should be in the right place by now, but make sure you're in the right place. This is Intro to iOS Development. Okay. So some announcements. The midpoint for A3 was due last night. This is just purely completion based. If you want specific feedback on your midpoint submission, just make like a private ed post, and we'll like make sure to give you like specific comments on it. But we're just gonna go in and like look if you committed anything to the repository and then give you credit for that if you have. Okay. The finals due next Tuesday. And by the end of this lecture, you should have all the tools you need to complete the final submission. Okay. Quick recap of what we did last time. Last time was networking 1. Basically, an HTTP request is basically what we use to communicate between the client and the server. Remember, the server, which is the backend, is out of the scope of this class, but we do need to get information from the backend. So that is in the scope of this class, and that's what we'll be, I guess, talking a little bit more about today, specifically how do we do that in Swift. And we will only be looking at 2 different types of HTTP requests, GET and POST. There's a couple other ones. Give me data please is not one, if you guys remember from last time. Okay, so yeah, so as another reminder, just remember that we use JSON to basically communicate between the front end and the back end. So like if the backend is in the backend course, they write backend in Python, but we write in Swift. So how can we communicate between those 2 languages? We do this with the JSON. And yeah, so basically we use these things called callbacks, which we spent a decent chunk of time on last time when making networking requests, so that basically we can get notified when that request is complete. So remember the analogy with, I guess, me picking up the phone and dialing somebody and waiting on the line until that person can return my call, versus me picking up, leaving a message, putting the phone down, and that person calling me back when they're ready, right? So they're 2 different things. One is a lot nicer than the other. Okay, and then yeah, lastly, we need to have all of our models that are being used in networking conform to this struct that's called codable, which basically has 2 structs inside of it. It's the decodable and encodable, and that will basically allow us to encode our struct, or basically decode or encode the JSON into our struct and vice versa, get the JSON from our struct. Okay, any questions about that before we move on? Okay, so yeah, real quick, just want to go over this thing called Alamofire. So Alamofire is basically an HTTPS networking library that's written in Swift, and it's built on top of the base Swift class called URL session, which is basically how you would make these network requests if you didn't have a package. But it's honestly a lot simpler to use Alamofire because they just make everything really nice for you. And so common cases that we can use Alamofire for is fetching JSON from an API. We can put some data to an endpoint. We can download an image, or we can use authentication with a REST API. And we won't be going into these 2 over here, but that's just some stuff you can do. Okay, so yeah, so also I want to talk about this thing we are gonna write. It's called NetworkManager. This is a class that we are basically going to include, and we are going to write, and it's going to handle all of our networking requests that we make in our app. So yeah, just like I said, we're going to create this class, and it's going to store all of our backend API calls. And essentially the main difference between this class and any other class that we're going to write is we only want this class to be instantialized once. We only want there to be 1 instance of this class available in our application. We don't want multiple instances of this class going around. We just want to have 1 instance that we can use everywhere inside of our project. So the way we do this is, first we have to prevent other instances from being created. So we mark the initializer as being private. What that means is basically if we try to call a new network manager somewhere else, Swift won't let us. It'll yell at us saying that the initializer is private, so we can't make a new one. But you'll notice that there is a static variable up here, right? Static let shared. And shared is basically the one instance of the class that we have. So because it's static, we can access it like from whichever file we want, just by calling NetworkManager.shared. And we'll look at that a little bit in a sec. Okay, so yeah, that's the main difference between like the Network Manager class and like other classes that we're writing. We're only gonna have one instance of this class. We never want to have more than one. So we are only having one instance, and that is a shared instance, and we mark the initializer as private so that we are not allowed to make any other instances. Okay, now let's look at some GET requests. Let's do a little demo real quick. So I guess just like we always do, head over to the website, get this clone command for networking 2. We're on lecture 7. So networking 2. And you're going to get this command here. And you're going to open up a terminal where you want it to be. Mine is inside of iOS course. And I'll open my terminal here. Okay. And then just like before, paste it in. And then I'm going to CD into that directory, which was called lecture 7 networking 2. There it is. And then I'm gonna do open space dot, and this will just open it in my file directory. And then I can click on the Xcode proj file once I have that open. I'll give you guys a second to do that. Yeah, so again, reminder, head to the site and copy the link. Then open a terminal and clone it, git clone, or you just paste it in. And then you have to CD into the folder that you just cloned. And then you can do open space dot, and then it'll open this directory. And then you can have access to all the project files and opening up the project in Xcode. Okay, so I'm gonna assume that you guys are okay with that. Let's move on. Okay, so here, the first thing, I just want to take a look at the overall structure of this. So we have a view controller, we have a model, and we have a view. And essentially what this is we have a, let's just run this actually and see what comes up. Okay, so we have like a table view inside of here, as you can see. And then we have this like members data, which is like the members that are going to show up, hopefully. Let's see. Come on. There we go. Okay, so yeah, we have this table view of different members. And there's like a little plus in the top corner. And if we look at the code right now, the members that show up on the screen on our phone correspond to this members variable here. Remember, it's in like the properties data. And if you remember back to like the table view stuff that we did, we have all like the table view setup. We have the table view data source that like basically uses members to make each of the cells. But essentially what we need to focus on here is the fact that our members data is hard coded, right? So if I look to where this dummy data object is, you can do that by right clicking and hitting jump to definition. So this will show you where something's defined. You see it's defined in this models member.swift, where the struct for the member is defined. But there's also this dummy data static variable that's basically a list of different members, right? So the members right now are completely static. If you wanted to go ahead and like add a member, you would have to do it manually inside of the code. But we don't want that. We want like the user to be able to add it, but also like we want to send it to our backend. And then that also means that we want to get our users from our backend. We don't want to get it from the hard-coded data that we have right here. So remember what I said, we are going to create a network manager class. And that is the first step in, I guess, transferring this code over. So inside of this lecture 7 folder, I'm just going to make a new group and call it networking. It's good to stay organized. And then I'm going to do right-clicking and do new empty file. And I'm going to call it networkmanager.swift. Okay, so nice. It brings up this very cool new file. So now let's, I guess, write the class. So it starts out with our like network manager, just like normal. And hold on, I have code completions on. Hold on, let me turn those off. Okay. Okay, so now we're basically going to, remember, we only want to have one instance of this class available. So let's define that instance first. So we're going to make a static variable that is that class, and we're going to call it shared. And that's going to be equal to the network manager, right? A new instance of this class right here. So it's kind of like interesting, but like there's a variable inside of network manager that like is a network manager. I know it's a little confusing, but it's only one, so it doesn't matter. So then what we have to do is we have to write the initializer, so init. But remember what we said before, that we don't want any other class to be like calling this or have access to this to create a new one. So we just mark the initializer as private. That's how you can do that. So if you don't want any other classes to be able to like call on that, you can just mark the initializer as private and it'll be fine. And also, we actually like don't want to do anything inside of this initializer. So you can leave it like this, but just for like, I guess, readability, I like to, I guess, put it like this so that you know that there's nothing inside the initializer. Because it might be confusing if you put it on different lines. Okay, awesome. So now we have kind of like defined that there's only gonna be one network manager. So now let's kind of create the, I guess, like the function that will handle like us making a request to our backend, right? So what do we want to do? We want to say, hey, backend, give me like a list of members. And backend will say, okay, like here's your list of members, right? So we need to make this request in this function right here. So I'm gonna call this fetch roster, right? So that's what we're doing in this function. We're fetching the roster. And now we're going to bring out some of the stuff from last time with callbacks and completions. We want to pass a completion handler into this fetch roster function. So basically what that means is when we call fetch roster, we'll have to pass it code that we want to run after fetch roster finishes, okay? So completion is going to be a variable that is the, is basically the like, what the code that runs after the function finishes. And what we want this to take in is we want this to take in a list of members, right? Because that's what we want from the backend. We want a list of members from the backend. And then we're gonna draw an arrow, and then that's gonna be to the return type of this function. And this function will just return nothing. And so a very important thing from last time that we kind of discussed a little bit was this notion of this mark that we have to put on called @escaping. Basically what that means is it allows the completion that we pass into this function to like continue running after fetch roster has finished. So if fetch roster finishes and we leave it like this, completion, no matter where it is in the like process of its running its code, once fetch roster finishes, completion will be no more. So it'll stop wherever it is and it won't like finish running. But if we mark it with this @escaping, just like this, then we tell Swift that, hey, completion can outlive the fetch roster. So even if fetch roster returns, the completion can still live on. Okay, awesome. So yeah, so we're taking in the completion and that's it. We just want to take in the completion. So we'll do this, okay? Now we have our function. So I guess the first thing that we have to do is remember when in Postman, when I like kind of had that URL that I was like calling, we need to specify that URL in here, right? So specify endpoint URL. So this is the endpoint we'll be calling. And so this endpoint is going to be on this, I believe. Okay, maybe not. All right, that's okay. We'll just, we'll have to type it out, which kind of sucks. I'll give you guys a second to type this out as well. 2, 3. Yeah, it couldn't have been something easier than this. Okay, so I have this right here. I'm gonna like proofread it while you guys copy. High scores G3. Okay, it's a good thing I proofread because I'm missing a letter. T-I. Okay, Q-Q-E-H-Q. U-A-N. Okay. Yeah, let me blow this up.
Oh yeah.
Okay. Yeah, that's the URL. I'll stop for another second so people can get it down. Okay. Yeah, so this is, remember I was putting like a URL into Postman the other day, and like this is like, I guess, similar to that. We're defining like what URL the endpoint is. Okay, next we basically now, like, remember when we get our response from the backend, our response is going to be in this JSON format, but we want to get it to our like Swift structures. And so in order to do that, we have to define this thing that's called a JSON decoder. They'll basically take that JSON and decode it into our struct that we have. So let's do that real quick. So we're going to define a decoder. So decoder, and this will be the thing that takes our JSON and turns it into our Swift struct. And that's going to be equal to a JSON decoder, just like so. Pretty simple. And it's going to yell at you and say that it can't find the JSON decoder in scope. That's fine. We just need to import this thing called foundation. That basically this is like what Swift has. Yeah, that's where the JSON decoder is. Okay, next, let me just mark this. Make a decoder. Okay, so now if we have some like dates going on in this, like maybe like the date that the member was added, we don't actually have that going on right now. But if we did, we would need to define a decoding strategy for that date on this decoder. So the way that we would do that is with decoder.date decoding strategy, which is basically like, so in JSON, the dates will come to us as strings, right? They will come to us as these like strings that look like kind of your month, date, year, like time, right? We might like have, which the code would have trouble, I guess, processing into an actual date object, which the date object is just like this in Swift. There's a date type. And so we're going to set the date decoding strategy. And that's going to be equal to ISO 8601. That's just like a strategy that basically your strategy on the front end has to match up with how backend sends it to you. So if backend's using this ISO 8601, then we want to decode using the ISO 8601. Okay, but again, this is only if you need to decode date strings, right? Okay, but it doesn't harm us to include it. Okay, cool. And then lastly, we want to define the like decoding strategy, the key decoding strategy. So if you'll remember from last time, these Swift structs that we write are in this thing called camel case, right? So the first letter is always lowercase, and then the other like words, the first letters are uppercase. But JSON strings JSON like format basically uses snake case, which is like similar to Python. If you guys have used Python before, it would be like something like this. Like let's say it's like member name in Swift, right? In JSON, that would be member underscore name, right? So it's two different ways of kind of naming the same like variable. And yeah, in Swift, our structures are going to be like this, member name, but inside of the JSON, it's going to be member underscore name. So we basically need to tell Swift that, and we do that by saying decoder.key decoding strategy, and then that's going to be equal to convert from snake case, because we're going to be getting our JSON in snake case, and we want to convert that into our camel case that we use in Swift. To camel case. Okay, cool. So now that we kind of have set up our decoder, we can actually like finally make the request. So before we make the request, we have to actually import Alamofire, which is the package that we will be using. Hopefully this is like already imported for you guys. It should have been with the whole like GitHub Git cloning. So yeah, we import Alamofire, And then the way that we make our requests is by doing this thing called AF and then dot. And then it's pretty based on like what you guys would think. It's this dot request. And there's a couple different ones here. We're not gonna like fill anything for now. We'll just write it out. But basically, like the first argument that goes in here is the endpoint that we have. So that would be endpoint, right? That we defined right up here, just like that. And then the second portion would be the method that we're doing. So remember, there's different types of requests. There's get requests, there's post request. So we would just want to do .get, right? Because we're getting data. And then there's two things we need to do after that. We need to basically validate the data, which is like make sure that the code that we get back from the backend is a 200 code, right? If we get like an error code, like a 400 or a 500, we don't want something bad to happen. So this is what this does. So we're going to validate it. And then we are going to basically take our JSON decoder that we made, and we're going to decode the data that we get from this request to our correct model. So the way we do that is we do response decodable. Response decodable. There it is. And there's a couple different things that goes in here. There's like this of, and then there's this completion handler. So the of is the type of like struct that we want to decode the data to. So this type that we want to decode the data to is going to be a list of members, right? Because we have that type member that we defined, and we are expecting backend to give us a list of those members. So the type would be a list of member, and then we actually need to do .self here to specify that we want the type of this. Okay. Then the completion handler is actually like what we have seen in the past. So this is like a function that you pass in that when the response comes back, it'll like pass it into this. So the way that we can do that is by we can actually just let's use another. There's a different one that we want where basically we have to specify like the decoder. So you'll see I started typing D and decoder came up. So we pass it the decoder. And then what we do is we write our completion handler outside. So this is like the same syntax as like writing it inside of the argument. If the last argument is a function, you can like extract it to outside the function, just like I did here. That's a little confusing, but this would be the same thing as like writing this completion and then like that. So passing it in directly versus just using it on the outside like this. And so, okay, member. So yeah, now it's going to yell at us that member needs to conform to this thing called decodable. So remember, this is what I was talking about last time, where our member needs to basically like conform to this thing called codable, which basically makes it like encodable and decodable. Okay, so now it won't yell at us for that, but it's probably going to yell at us for this. Okay, yeah, so now remember this completion handler. Once the response comes back to us, we are expecting like to get a list of members. So this is yelling at us right now because this completion currently says that like we're not getting anything, but we are getting something. We're getting the members, and then I'm going to say in. Remember, that's just the syntax for that. Okay, so now by the time we're in this chunk of code, we have the members. So awesome. Okay, now let's handle the wait, hold on. This actually let's take a look at this and make sure. Okay, so this is a data response of members or an error. So basically we need to check. I'm going to rename this to response. So this is the response that we get. I need to check. Right now we need to check and make sure that the response has succeeded, right? So we're going to switch the response.result. Result. Cool. And then we're going to write a case for when it is dot success first. And then this will be where our members are. So let members. And then we have to do a print of, we'll just print out successfully got members. I'll put a string, interpolated string in here, and we'll say how many members there are, just to give us some outputs. Members dot count. So successfully got however many members. And then we need the other case as well. So case dot failure, right? Because it can fail. And then we're going to say let error. And we just want to print that error. And we'll specify where this error happened so that we can, I guess, debug in the future. So we'll say like error in NetworkManager, because that's where we are, dot, and this is the fetch roster method, right? So error in this, and then we will also include the error in there so we can see. And then also one thing we forgot to do is in the success case, remember, once we get to the end, once we get all the members successfully, there's this completion that we're going to pass in that's going to tell us, hey, what are we going to do with those members? So what we have to do is we have to pass the members to that completion. So we just pass the members in, just like this. Okay, I know that's a lot. This is the whole function. This is the whole function. Just to reiterate, you specify the endpoint, you make the decoder, and you modify the decoder to however you want. Then you make the actual request, and you put in the endpoint, the method, then you have to validate it, then you decode it, right? And you define what you're decoding to, which is an array of members. You put in the actual decoder, which remember we did up there. And then you get this thing called a response. You switch the response and you check if it's a success. If it's a success, awesome. Pass the members into the completion. If it's a failure, then we just print what the failure is so that we can decide like what we need to do going forward. Okay, awesome. So that is all good in that file. So now we need to get rid of this like members dummy data from these members so that we can actually use the networking data. So first thing I'm going to do is I'm just going to flip this to an empty array. And remember, if we have just an empty array without anything in it, we need to specify the type because Swift doesn't know what type it should be. So it's a type of array of members. And then what we're going to do is inside of this view did load, what you'll notice is that like the table view has no, like we have no way of calling on the network manager right now. So I'm going to create a new function that just calls the network manager and passes in the completion that we want and then gets it all back. So I'll make a new private func. I'll call it fetch roster. And this is going to take in nothing. And then now remember, we have this thing called a network manager that we just made. Here it is. And look where our shared instance is. It's right there. And we can call it. So this is our shared instance that we can call from any class, anywhere. We don't have to make a new instance. And we're just going to call, look at this, fetch roster, the function we just made. And you'll see it's a completion. We pass in a completion that takes in a member and returns a void, or yeah, that handles a member and takes in a void, or and returns a void. And so if we press enter on that, if you guys see what I just did, you just like, you're on here, it's blue, and you press enter. This is like the name of the variable of the list of members coming in. So we'll say members in, and this is the code that we want to run on the members. Okay, so there is a first let's start with like the main thing. So we want to I guess set the members that was up here, right, in our properties to be members that we got from the networking request. So the way we do that is by doing self.members equals members, right? But there's an issue. So if we just do this, all we're doing is uploading the data or updating the data. We're not actually reloading the table at all. So what we need to do is we need to tell the table view that, hey, our data was updated. You got to refresh. So we'll do that by just doing table view dot reload data. Very simple. I'll also call self here to, I guess, talk about something very important. So inside of these completions, there is a very small edge case where you will get memory leaks, where basically what will happen is if this function here outlives the actual class itself, then we won't be able to have access to these members and table views, and they'll just exist. This function will try to exist in memory, but will never resolve because it can't access these two things. So basically, like, that's like a very, if you understood that, good for you. But the only thing we need to take away from this is that we have to do something called guarding self. So we're going to guard and make sure that we have access to self inside of this completion handler so that we can actually use this self.members and self.tableview. So the way we do that is before our argument over here, we put this thing like that looks like an array, and we say weak self. So we basically mark self as weak. So weak self members in, right? But now what this basically says is we don't know if self is like available here, which self, remember, refers to the class. We don't know if self's available here. So now Swift is going to yell at us saying like, oh, this self is like now optional. You marked it as like maybe it's not here. So now what we need to do is we need to guard let self, and then we are just going to put an else statement where we return. So what this line is doing is saying, hey, like make sure self exists or return. Okay, that is confusing, but just know that if you're putting like completions with like networking requests, you should always like guard self and define like self as weak, just to be safe, because you could get memory leaks. There's a edge case. Okay, so one more thing that we have to do is so this completion, remember, is done asynchronously, right? So it's done in the background, basically like not on the main thread. So the problem with this is if we run this self.tableview.reload data in a background thread, it might like perform that update at the wrong time, or it won't be like synchronous with the front end. The idea is that we always want the main like UI updates to be done on the main thread, on the first thread that happens, the main thread. That's where all the UI is being updated and running. So basically the way that we need to do that is by calling this thing called the dispatch queue, which again, you don't really like need to know too much about this. Just know that it like handles different threads. And then we're just going to do the main thread, right? Because dispatch queue.main, so this accesses the main thread. And then we are going to run something asynchronously, and we are going to execute this self.tableview.reload data on the main thread. Okay, so that's the last thing that we needed to do. Let's see, perform UI update on main thread. Okay, I'm gonna get rid of these selfs because actually this one is good, but I'll keep that. Okay, so let's now, last thing. Oh shoot, yeah, actually we do need to include self here. Self.tableview. Okay, so then the last thing we need to do is remember we didn't actually like call this function anywhere. So after we set up our table view inside of this view did load, we also want to make the networking request. So we're gonna call this fetch roster function. So I guess gotta like tracking through it one more time before we run. So remember, when the view loads in this view controller, set up the table view and fetch the roster. How are we fetching the roster? We're going to our networking manager and we're calling the fetch roster function that we made. Fetch roster, when it's finished, will have like the members there that we got from the backend. And what we're gonna pass in is this completion here. This code here is gonna run on the members that we get. So that members in is what gets returned to us. And what do we want to do? We want to update self.members and we want to reload the table view. Okay. Yeah, let's run this quick. Okay, there we go. Cool. Okay, so it took a second, but here it is. All right, and now I'm gonna hand it over to Belle to talk about the other stuff.
Okay, so right now we're basically just fetching information from the backend, but what if we want to push information onto the backend? Basically make a post request and create a new member added to the backend. So now we're gonna talk about how to handle post requests and send information to the backend. So okay. So if you go to your network manager, we're going to define a new function, kind of like how we define the fetch roster. We're going to define func add to roster. And basically, what do we want to do? We want to take in a member object, and then we want to send it to the backend to basically create the member object. So it's going to take in a parameter member of type member. And then similar to how we had a completion handler for fetch roster, we want to have a completion handler for add to roster. So make sure to put at escaping so it can live on. But this time the completion handler, instead of taking in an array of members, will take in a singular member. So make sure that you don't put the brackets, so member, and then make sure it returns void, so it doesn't return anything. And then put the parentheses around that. Okay. Cool. And then right now, we want to convert essentially a struct of member to a JSON format. And so let's go back to our member model. So our member has properties name, subteam, and position. And in order to convert to this JSON format, we use something called parameters. So parameters is basically a string dictionary, and it's going to be mapping your properties to essentially the value, the parameter member object you're taking in this function. So what we want to do is have a constant, so let parameters, and it's going to be of type parameters. And we want to map every single property from member to the value. So, for example, name, let's map that to member because we took in a parameter member and access its name property. So go back to the member models, the struct, and then it has a subteam. And you can access the subteam like this, and then also has a position. Be really careful that you're spelling these keys correctly, because if they're even a single character is off, everything's gonna fail. So I'm just gonna look at this real quick. So name, subteam, position. Cool. So this is basically what we're going to feed into the backend to say, hey, create this new member object, but it's in a JSON format. Now we want to basically ping the backend using Alamofire. So use AF, similar to the previous function we wrote, AF.request. And it's going to take an endpoint again, but this time the method is not a get request, it's a post request. So put .post. And similar to last time, we also want to call validate to make sure that there was no issue from the backend when the backend passes our data back. Oh yeah, so we don't have access to endpoint right now, but one thing I want you to observe is that in this demo, our endpoint basically pings a base URL. So this endpoint is going to be shared among both the GET request and the POST request. This is not always going to be the case. For the sake of simplicity, it is for this demo, but in maybe your hack challenge, if your POST endpoint and GET endpoint are different, they'll at least share a base URL. So basically maybe the POST endpoint will have that base URL with some additional stuff on the end. And you can use string interpolation to add everything that comes after the base URL. But again, for the sake of this lecture, we're using the same base URL. So for the sake of good code quality and more readability, I'm going to take out this common code that's going to exist in both our fetch roster and add to roster, and I'm just going to define it at the top of the class. So I'm going to take out, we don't need this stuff for this section, so I'm just going to comment this out. But take the endpoint and also the decoder, which we're also going to use in both functions. So we can take the endpoint and the decoder, take it out of fetch roster, and then put it at the top of the class. So now endpoint is valid, right? There's no error on endpoint now in our af.request and add to roster. So after we validate it, similar to how we're doing it in the fetch roster function, we want to call response decodable. And then this time, instead of taking in a array of members.self, make sure you do member.self. And we also take in a decoder. It's just a decoder that we declared at the top of the class, if I can spell that correctly. And also, it has a completion handler. So we have a closure here. And this is going to define when the backend gives us stuff back, right? Like the backend says, hey, I created this new member object. Here is some information. So even if we're creating a new member object, the backend is still going to say, hey, here is the new member object that you've successfully created. I'm going to give it back to you. So it can be kind of counterintuitive, but even when you're creating a new member object, in this case, the backend is handing you that member object back to say, hey, we successfully created that member object. So what you want to do is, in the case of like this closure, it will take in that response from the backend. So we have a parameter, essentially, response from the backend. So this is syntax, response in. And what do you want to do with this response that the backend has given you? So basically, similar to before, we want to switch off of that response. So switch off of response.result. We use a switch statement to say, here are the two cases, right? Kind of like an if, else, if. So we switch off of the result. And our first case is similar to the last time. If we have a success, that means we have a member. And we're going to do something here. So it's going to yell at me when I currently don't do anything. I'll fill it in later. We're going to handle the failure case first, actually. So when we have a failure, we have an error. So in the case of an error, it's helpful for us for debugging to have a print statement. And we're just going to print error in NetworkManager dot add to roster. And we just want to use string interpolation to print out a localized description of this error, like this. Okay, so then in the success case, we also want to basically print that we successfully added this member, but we also want to call the completion handler to say, hey, take that member object that the backend has passed me and then give it to the client in the front end. So what we want to do is, like I said, first call the print function. And let's say we successfully added, use string interpolation here, member.name to the roster. And then afterwards, call the completion handler on that member object to pass it along. Okay, so no errors now. So at this point in time, we've successfully implemented add to roster, the underlying function that basically hits that base URL and says, hey, create a member object for me. Now go to the view controller, and then let's go to the function add new member. This is basically, okay, yeah, so we can't see it now, but earlier, if I go here, we want to basically press this add sign, and then we want some new member to appear at the bottom. So let me go back to Xcode. So in add new member, we need to first instantiate, we're going to basically create a newbie, right, to pass to our backend. So let's write that here. So let newbie, and then it's a type member. And it takes in name, so let's do Angie, she's over there. And then her subteam is iOS, and she's a member. Okay, so now we have created an instance of the member object, and now we want to call that add to roster function that we defined in NetworkManager. So let's call NetworkManager and like the shared instance that we've been using. And then you can see it shows up right here, add to roster. And we want to add this newbie that we defined, Angie, and then we also have a completion handler. And this completion handler is defining, okay, when the backend gives me that like data back, what do I do with that data, right? The backend says, hey, here is that new member that you've created. I'll give it back to you. So similarly, to avoid memory leak, just put weak self for good practice. And basically, the backend gave us a member back. Oh, don't do that. Yeah. And then just similar to how we handled fetch roster, we want to make sure that the data exists. Otherwise, we just want to like break and return. And if it does exist, in this case, we're just going to print that we successfully added this member. So we can do member dot position, and then member dot name was added to the member dot subteam. Yeah. And then notice here we're using an Objective-C function to do basically say, hey, when that plus button is tapped, so like, okay, where add new member is called, you can see in view did load right here as a selector. It's basically when that plus button is tapped, call this function add to member. Okay, so now if we, now let's run the code. So Command R. And if I press plus, I want to see if, so Angie does not appear at the bottom. So that actually is the problem. I think the only way that Angie will appear is if I like basically restart the app. So I go back in, and then now if I scroll to the bottom, okay, wait, make sure it's running. Add new member.
Try doing the add. Wait, something with the response. With the network manager.
With the network manager?
Yeah. Look. 400 error.
Okay, wait, one sec. Localized.
Response status code was acceptable. Do you have the? Where's the number? Oh, you need the parameters.
Oh yeah, I made a oof. So earlier I basically I converted the struct to the JSON format, but I actually never passed it into the request with an Alamofire. So if we go to Network Manager, my line 50, in the call to the request, you have to pass in parameters. So it has a parameters argument, and then you pass in that parameters constant that you define. So wait, let me run this again. Okay, I'm gonna call add, and then see. Okay, she's added at the bottom. Good. So the problem is I had to basically restart the whole app in order to see her like appear at the bottom, right? What we want ideally is to be able to like swipe down and then see her automatically appear without like having to exit out of the app and re-enter. So what we want to do now is go to the view controller. And basically we want to define a new property, and it's basically going to be a buffer, so like a spinning symbol, that when you swipe down it's going to spin and then tell you, okay, now you can go swipe, look at the bottom and see this new member is added. So at the top of the view controller, define a new property called refresh, and it's going to be UI refresh control. And then you want to go to the setup table view, and basically we want to say refresh.add target, and the target is going to be self indicating this class, and the action takes in a selector. The selector is going to be fetch roster, and for dot value change. So what this is saying is that when the refresh, like the spinny thingy, detects that the value has changed on the page of members, right? The array of members has changed. When the value has changed, call fetch roster and rescrape all the member objects so that we can have an updated list of member objects to display. Fetch roster. And so now it gives me an error. So go to fetch roster and make sure you add at Objective-C. I can't spell. Objective-C. and that should get rid of the error. The next thing we have to do is basically attach that refresh control object to the table view. So you want to call table view dot refresh control property and assign it to that refresh object. And then the next thing we want to do is to avoid a bug where it's just continuously spinning and spinning and spinning, we want to go to fetch roster, and then underneath in the dispatch queue, we want to tell it when to stop spinning. So self.refresh and end refreshing. Okay, so now if I run this, and I'm gonna add, and now if I pull down, you see the spinner happen, right? Oh wait, I think for the sake of this, I should create name the person something else so that you can see a difference. So let's put another person. So Adeline, who's not here, but she's also a newbie. We're gonna run this again, and this time you should be able to see a difference. So if I press add, and I want to scroll down to get the spinner, and then at the bottom we should see Adeline added, like that. So yeah, there we go.
Okay, yeah, so that's, I guess, how you do all that with the networking. So yeah, we demoed get and post request, and also refreshing. And now let's get to the Kahoot really quickly. Nice sound.
Yeah, and if that was too fast, because we were a bit short on time, go to the course textbook and you can get checkout and look at the finalized code.
Yeah. Yeah, if you ever need the finalized code, it's on the course website under the lecture. I don't want to pull it up now because then people can't see the thing. I'll just pull it up real quick. So you just you go to networking 7, clone the repository, and check out the third one down here. Okay. Who's not in the Kahoot? Okay. Anyone else not in the Kahoot? Okay. We're starting. Oops, someone joined. Okay. Okay. First question. What is the name of the library we'll be using for networking requests? Yeah, nice. Okay, good. Yeah. I thought I would trick more people with that, but nice job. All right, nice. Next one. True or false? We mark our networking manager initializer as public. I like how quick the numbers are tallying. Yeah, it's false. So remember, we mark the network manager initializer as private because we don't want anybody else to be accessing it. Okay, nice. Okay, so marking a closure with .escaping makes a closure run immediately when the function's called, allows the closure to outlive the function it's called from, allows the closure to run away from the original function, or gives the closure unlimited paid time off. Yeah, nice job. Yeah, it allows it to outlive the original function that it's called from. All right, last question, most important question, is a multi-select. What is the best anime?
Think about Peter and his preferences.
The photo.
Wait, I don't know why it said multi-select. There's only one right answer. Yeah, Jujutsu Kaisen is the correct answer. I don't know why it was multi-select when there's only one answer. But, yeah, okay. Okay, let's see the podium. Nice. All right, while we're waiting for the podium, I'll just say that if you guys have any questions about the hack challenge, please like reach out. Hack challenge is coming up pretty soon, and we'll be sending stuff out about that. Let's see, I think next week. Okay, so yeah, find friends in the backend course to I guess like be grouped with. All right, good job guys. Have a good night. Thanks for staying late.